Hello, and welcome to Converting a React App from JavaScript to TypeScript with me, Josh Goldberg. Everything in this workshop is available online and open source. The URL for the repository, as you can see on the screen, is joshua.k.goldberg/nextjs2ts on GitHub. It's also on my Twitter and website, both of which are Joshua K. Goldberg. The website is .com. I'll also post links in the TSConf chat. Go TSConf. What we're going to do today is convert a React app from JavaScript to TypeScript, which will involve creating a TypeScript configuration file, getting Next to run with it, converting all the components, libs, hooks, etc. in this app from JavaScript to TypeScript, fixing any type complaints along the way. And then we'll lint it with TypeScript Eslint on top of the regular Eslint. Exciting stuff. Let's begin. To start, we have this repository, Next.js2ts, which you can clone locally. I will do that in iTerm. Git clone, paste the URL, joshua.k.goldberg/nextjs2ts. Personally, I really like VS Code, so I'm going to open it in Code. Code has really good built-in TypeScript settings and IntelliSense, but you can use whatever editor you want. There we go. Nice, it's open. The instructions for getting this running are in the README. First thing you got to do is npmi or npm install. You can use yarn if you want, but for portability's sake, I'll just use npmi. There we go. Like any good Next.js app, this is pretty much based off of Create Next App, which is the really nice standard toolkit that they provide for making a new app, similar to Create React App. I did not use the TypeScript option of CRA because well, I wanted to show you how to do it myself. Same with CNA. Going over the components real quick, we have a few folders that will convert. Components, data, hooks, libs, pages. Styles is just a CSS file. Once this finishes installing, I'll just clear all that junk. We'll do npm run dev to start the app locally. It'll be available on localhost 3000. So I will click this, let it load for a bit, and wait for you to catch up if you'd like to and you're running at home. There we go. The basis of this app is that it is a very simple movie app that shows some of the movies I've seen and remember. They're sorted by name, by default A to Z. You can sort them C to A, year to new to old, year old to new. You can also star them, filter them on those stars or favorites, whether you want to see only favorites or no favorites. Okay, cool. It's a pretty small, very basic Next.js app. If you'd like to see more advanced conversions, feel free to talk to me directly. I can show you some wild things. But anyway, maximizing these windows again. The first part of any installation of TypeScript, any conversion to it, is installing TypeScript itself. npmi TypeScript save dev. That's the first command we'll be running, which installs TypeScript as a dev dependency. Personally, I also really enjoy having TypeScript available locally, so I do npmi-g TypeScript on my computer, which installs it globally as a dependency, or rather globally as an available package on my computer. The reason why I like this is because then I can do commands like tsc-init globally. tsc-init creates a tsconfig file for you, which is the file that TypeScript uses to understand what settings to run with and what files to run those settings on. By the way, if I ever open a file by this lovely little dropdown on Mac, that's Command P, on Windows that's Control P, I believe. tsconfig.json. Enter. Let's talk about this file a little bit. First, I'll move this comment up here because that's how I like my comments. Anyway, this file has all the compiler options that we're going to be running TypeScript with. Anything that's not the default is mentioned here. To start, I'm going to set target to ESNext. This is the type of language I'm going to be allowed to write, like what level, what fanciness level of JavaScript. The module system is going to be ESNext, meaning just let me use regular old new ECMAScript modules. Don't force me to use like AMD or whatever. These are more relevant when you're using TypeScript directly and not through a framework, so I'm just going with the basic, let me do what I want. Very relevant, though, is strict mode. I'm going to enable strict true to enable all strict type checking options. Now, if you are converting a large app from JavaScript to TypeScript, it might be easier for you to disable the strict options and then later on enable them when you have time. I'll show later on an example of why that might be easier. But because this app only has a few dozen files and I'm feeling feisty and good in this workshop, I'm going to keep all these strict things on. We'll see later what some of them do. I'm going to delete all these commented outlines. ES module interop makes it a little easier if some of your node modules have like weird, funky ways of default or complete exports. Skip libcheck is a little nice performance improvement and makes it easier to not have weird errors in your dependencies. It skipped type checking of declaration files, so we'll go over declaration files soon. And lastly, this one isn't super duper important to the type system, but force consistent casing in file names is really nice because, well, it disallows inconsistently cased references to the same file. If you have the wrong casing of a name, TypeScript will yell at you. Spoiler, that happens here. So nice little utility to have. Lastly, and you definitely don't need to be like me and do this, I like using the VS Code sort lines ascending, Command-Shift-P or Control-Shift-P menu to open these commands. And sort lines ascending makes me feel like my config file is nice and organized. Okay, we have our tsconfig. Let's run our server. Now, Next.js, when it sees the server, will notice that you have TypeScript in it. It'll see that you have a tsconfig, and it'll add a few default settings to that tsconfig file. And just saving, formatting, and then sort line ascending them to keep my own nitpicky preferences. A few things that they changed, they make sure that you have the right React or JSX settings so that TypeScript recognizes you have a React global. Lib says what built-in types or global values are available to you, and say DOM or iterable elements of the DOM. A few other small things that you don't really need to focus on too much here. Include says we include all the TS and TSX files, which is quite important. We want TypeScript to know these are the files to run on. And we get this nice little nextend.dts file. Let's go into that a little bit. Nextend.dts, copy and pasting into the file open command, is a declaration file or DTS file. Declaration files, such as nextend, tell us global types or module types that are meant to exist, even though they're not written in our code. If you have some global environment like Node in the browser, or if you have some pre-built libraries you're using like Next.js and class names, the NPM modules, then those can be referenced in your @types definitions, which is a type of package that you might install, and or through these little /// or / references in your DTS files. Here this one says a couple things we care about. First, it says that we have a reference to the global Next.js types, which includes Node, React, and React DOM. And you can see all these fancy Next.js types like get server-side props context and get static paths, which I'm not going to go into. And also declares a few Next.js global types. Here we say that the process has a nodeenv string, which is one of these three values. Already TypeScript is giving us value here. It's telling us exactly what things are allowed to be. And it's saying in the type system that any module that, or any file path rather, that ends with .module CSS or .sass or .scss has these contents. So if we look at a JS file already, let's say our index page, and we look at, say, styles.unbroken, here it says that it is an any type. But if we were to say, go down to, let's go to a leaf node, say footer, still any, and then rename this to a .tsx file so that we get nicer TypeScript type checking in here. TypeScript would tell us that styles is an object that has key type string and value type string. So styles.logo is in fact a string. Same with styles.footer and other styles. So this is one of the key tenets of converting to TypeScript. The stuff that you don't control in your TypeScript code, like your CSS module transpilation settings or your NPM modules, Those you would bring in with definitely typed or DTS packages. And we'll look later at actual definitely typed packages. For now, it's just this little DTS file. So you might be wondering, how did I conclude to go to footer immediately? When I convert files from JavaScript to TypeScript in a project, I like to start with the project's leaf nodes, meaning the files that don't have dependencies in other JavaScript or TypeScript files in the project. If you were to map it out like a tree in the graph theory sense, it would be the leaves, the leaf nodes. So I started at index, which is the home page. I went to the first import, command clicked on that. Then I command clicked on its first import, and that brought me to footer. Now, if we look at the React components and we hover over them, this footer element, all these basic DOM ones, we see that React knows what types these are supposed to be. It knows that the HTML attributes for an HTML element, has a class name which is optional and can be a string or undefined. And if we go to definition on that, that's because we've had an types package, which was installed for us by Next.js as a dependency. Node modules, types React. This is the definition for all your different React props and React APIs and JSX elements. Class name can be a string. Fun fact, content editable can be inherent or something like a Boolean, which is Boolean or the strings true or false. There's a whole world in here. This file is huge. If you really want to read through all 3,000 plus lines, you do you. But for me, I just like knowing that it gives me good type IntelliSense on my JSX elements. Anyway, let's look at our server. Hello world, yay tsconf. Let's make sure that things are updating nicely. So I've added some text to my footer component. And I'm going to refresh the page, scroll all the way to the bottom. No text in the bottom. How unfortunate. I have noticed that in a lot of frameworks, libraries, you need to delete the cache when you're changing the core language, the thing the app is written in. So I'm going to kill my server, Control-C it, and delete this .next folder. I just deleted it. And I'm going to clear npm run dev, which goes straight to the command next dev. And hopefully this will have cleared the next cache, which is stored under .next/cache. And once my server finishes loading again, yay! I have, you can see on the bottom left, my little hello world yay tsconf. So hooray! All of a sudden, without any prior warning, I have converted the first component from JavaScript to TypeScript. Notice how the file is TSX. TSX is the language extension for files that contain JSX. And amazingly, there is no new syntax, which is a very important theme for converting to TypeScript that I'd like to hone in on here and really enforce. There is oftentimes not going to be that much work to do when you convert a file from JavaScript to TypeScript. Some files are complex. Some files are going to have wacky, zany things in the type system and all sorts of declarations and annotations and stuff. But ideally, you want to have as little work as possible when you're converting from JavaScript to TypeScript. Ideally, TypeScript should be able to infer types from your code. In this case, it sees that it's a React component, or really it's just a function that happens to return a JSX element. And it knows that styles is of type string to string. It knows that next image was declared in the Next.js type definitions. And voila, it should just magically work. Yay. Going back, yep, my little footer notice is gone because I saved. So yay, we converted our first component to TypeScript, and all we had to do was change the extension. Let's convert the test. Now, footer test.txx is a pretty standard small test file. It uses a cute little utility I like called component setup that wraps around RTL, which is a great little testing library. Takes in a component, some default props, and gives you a function to render with any prop overrides. And here we see our first red squiggly. So let's get excited. It's our first TypeScript complaint we have to fix. It's saying, cannot find name describe. Do you need to install type definitions for a test runner? Try npmi save dev types jest or types mocha. I mentioned we talk a little bit about definitely typed. Some JavaScript packages don't come with their own TypeScript types. They don't come with their own DTS files that TypeScript can then read under node modules. For those JavaScript libraries, the ones that don't have their own types, we source those types from a huge repository called Definitely Typed, which then publishes to packages under the app types namespace. You can then install them as dev dependencies. So I'm going to do that here per the TypeScript suggestion, npmi -- save dev types jest. Shouldn't take too long. And once it does install, here we go. Soon, yep, TypeScript recognizes that now we have types for just describe, which it recognizes is a function that takes in a name and another function and returns nothing. Very cool. Let's start my circuit again. Let's hide this. And you know what? There's nothing really else we have to do for this test file. Again, now that we've installed the right type definitions, magically it works and compiles in TypeScript. And if we go back to our local server, yep, this thing still works. Cool. I'm going to go back to the file though, and I just want to make sure. We do npm run test footer test tsx, which runs jest on the footer file. This is actually going to give us no test found exiting code 0 or 1 error. And the reason why is that we don't actually know how to compile TypeScript files by default with the default jest Babel settings. So in my jest config, a few things are going to have to be changed here. For starters, module file extensions, JS and JSON, this is saying the modules that you might load. If you're using a typical jest, so React test, then, well, you're going to have to add TS and TSX so that jest recognizes that those are modules or files that you might want to load. You're also going to want to add to your transforms. If you're transforming with something like Babel jest, most configs by default, if they don't recognize TypeScript, say only files like JS or JSX, you're going to want to use TS and TSX as well. If we have our own Babel jest config, then we're going to have to add one last little piece here. Now that we know we need to compile TypeScript files using Babel jest, we need to tell Babel how to compile JavaScript files from TypeScript files. And for the sake of workshop, I don't remember how to do that, so I'm going to look up TypeScript Babel or TypeScript Babel preset because my browser auto-completed. Cool. So Babel has a preset for TypeScript, and all you got to do to install it is this one little line, npmi save dev Babel preset TypeScript. This is a preset set of settings and libraries that'll let your Babel tool chain take in TypeScript files and output JavaScript files, just like it normally would take in JavaScript files and output other JavaScript files. And while it installs, the usage recommendation is to add this string to your presets array at babel/preset TypeScript. So I'm just going to go ahead and add that to my array. So to recap, I installed Babel preset TypeScript after adding TS and TSX to my extensions in my jest config. I added to my Babel jest config the preset. Now if we do npm run test footer, I'm going to put it in watch mode just so I can make changes and see them quickly. It recognizes the test file and it passes. Just to be sure, I'm going to throw an error. Yippee! Nice. The test throws an error and fails. So congratulations. Not only have we converted a component to TypeScript, we've also converted its test to TypeScript. Yay. Very good. Let's npm run dev. Most of the rest of this talk, this workshop, is going to be me going through files and converting them from JavaScript to TypeScript. Great. So we've used the footer as an example. Now let's go back up to see who imports this leaf node, back up the dependency tree. And we see it's used by layouts, which imports footer and just a CSS file. So now layout can be thought of as a leaf node, and that we need to convert it to TypeScript. And to do so, I will rename it to layout.tsx. Aha. And immediately we have 2 areas of red squigglies, TypeScript complaints. Now I'll note, if you wanted to, you could run TypeScript in watch mode in the package JSON under scripts. I do have a missing thing here. Let's put a compile script. Compile tsc. So if we do npm1 compile -w, let me pause that so you can see it. Ooh, almost. Yeah. That just runs tsc in -w or watch mode. -w. TypeScript on the command line is quite good and fast. It will give you complaints. Oh boy. Those complaints are, when you have them, are the same as what you see in your editor. And although the 4 errors are very clearly laid out in the command line here, look at them all at once, I personally find it easier to convert code en masse in the editor, 1 file at a time, and then look in the command line later to see if I have any complaints that I missed. And in general, when converting a React app, just any app from JavaScript to TypeScript, I personally find it much easier to go 1 file at a time, to start with the leaf nodes, as I mentioned, and then to convert incrementally. If you are using a framework that needs everything to be in 1 language at a time, then that can be a little difficult. But with TypeScript and most TypeScript supporting frameworks, you can do something like allow.js true, which was added for us by Next.js. That says that you can include JavaScript files in what TypeScript understands, but it won't type check them. It doesn't include check.js true, which would tell TypeScript to also type check your JavaScript files. This way we can include JavaScript files in our project, but we don't need to type check them, which is a little easier to start with. Anyway, let's get back to converting to TypeScript. I'm going to npm run dev, just so I have my server at the ready. And let's look at these 2 areas of errors. To start, footer. It's telling me file name, blah, 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 footer tsx differs from an already included file name, blah, 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 footer.tsx, only in casing. Well, here it's a lowercase f to start the name, and here it's an uppercase f. And if we recall back to the file, it was uppercase f footer, and here it's a lowercase f. So a quick fix, thank you TypeScript, is to change it to an uppercase f. Voila, it is fixed. Cool, that was easy. That was our first TypeScript real complaint. Yay. Now, I want to note that I am running the local dev server in my terminal. I can access localhost 3000, I can use the site, but there are TypeScript complaints. We still got 3 complaints here, 3 red squigglies. A good TypeScript toolchain should still let you use your website or whatever app you're running, even if you have some type errors. The syntax is still totally valid in this file. This is still a totally valid JavaScript output, but you have type errors. Oftentimes in development, you will still have a totally functional valid app, but you won't have fixed all your type errors yet. So it's important that whatever settings you use allow you to keep running even if there are complaints. In this case, the complaint is that we don't have an interface or some way of declaring what these props are. And the common way to do so is to create an interface with the component name, then props, and declare that the first function's parameter is of that type, layout props. Here, let's see, we have children, description, and title. Now, for those of you who aren't super new and snazzy with the JavaScript syntax, what we see in this file is basically the same as this, where we have a single parameter of that type, and then we destructure the parameter immediately. These 2 lines are the same as this line. It's just this line is snazzier and only 1 line of code instead of 2, so we tend to use it. And now here we have the 3 red squigglies moved. In both places, in both forms, they are an implicit any. If we don't declare the interface type as the type of this object, then these are implicitly any here. If we do declare the interface type, but we don't say what type the members are on the interface, they're implicitly any here. Remember, children implicitly has an any type. Implicit any means TypeScript wasn't able to determine what type the thing was, parameter, variable, member, whatever, and thus has to give up and say, it's anything, I don't know what it is. Implicitly meaning it's not explicit. You didn't explicitly say this is of type any. It's just implicit. And this is the majority, I find, of the time when converting something from JavaScript to TypeScript. Seeing things that are implicitly any, they can't be inferred, and having to manually declare what type they are. There are a few strategies you can use when you're fixing up no implicit any's. To start, you can guess. Most of the time, a React node that takes in children will type it as react.reactNode. As in, this children can be any React node, which is a JSX element, a fragment, a Boolean, a portal, null, whatever. You can also verify your guesses. And let's right-click on the element and find all references. Here we see layout is only ever used once, and it's in the index file, the home page. I'm going to put these files side by side. Let's see, where is layout used? Here we go, line 14. Well, to start, description and title are passed in as strings. Description is this thing, title is this thing. So I'm just going to call these both string, because that makes sense to me. And we can see in their usage that that works. Title is passed as a child to this title meta, and description is passed as content to this meta, which is typed string or undefined. Ooh, there we go. Hovering over content, we see it's meant to be either a string or undefined. And here the description is string. Good. In general, children being of type react.reactNode is pretty common and pretty reasonable. If you're passing in a bunch of JSX elements to the component as children, it's probably a React node. So great. We have converted our first component to TypeScript. Yay! In that we converted its syntax to include TypeScript-specific features. Footer was really our first component. Awesome, that feels good. Let's move on to the test. Layout.test.tsx. And you know what? There's nothing I have to do here. Great. That being said, I do want to showcase a pattern that does happen a lot. Suppose you have a test that looks like this. You set up a let view, and you do like a before each view equals setup RTL, or what is it? Render view. In in Enzyme world, it might be like let wrapper equals render layouts. This is what it might look like in Enzyme. This is what it looks like instead in this setup RTL wrapper we've written. This is what's technically called an evolving any. It is implicitly, an evolving any variable. It is implicitly any to start, meaning TypeScript won't infer from later usage. It just sees what it's initially declared as, which is nothing, so any. And later on, it knows what type it is. In this case, it's the return result of render view. So it can be useful to manually declare what type things are. In this case, what is render view? If we go to definition, we see it's the return result of setup RTL. If we go there, it's render RTL return. Here is a pro tip. If you ever see really complicated TypeScript types like this one, just ignore the ones you don't need. I have just directly navigated to the result that I need. And we see here that the view is a render result. So just completely skipping over all this junk, we see render result is returned from testing library React. So I'm going to take that. So let view render results. Oh no, it's actually this. Haha. Okay. And the way you might write that in code is like, let's say you're doing RTL directly, you might do like a render layout. Oops. Description. Title equals title. Oh. And now we see why I wrote this little wrapper around RTL. Oops, we have a lint rule. All right, here we go, finally. All this is to say that if you have a library where the test files tend to use before each to set up the view instead of making them unique per test file, and you have some kind of let view or let wrapper variable, what you might want to do is add an explicit type annotation on the variable so it's no longer an evolving any, it is explicitly the type you expect it to be. In the case of RTL, that's render results. In the case of Enzyme, it's shallow wrapper or React wrapper, some name like that. I don't use Enzyme so much anymore. Awesome. But none of this is necessary because we're not using RTL. Haha, directly at least. All right. Moving on. We have layout, and moving up the dependency tree, layout is rendered by right-click, find all references, the test, fair, and the homepage, great. But before we convert the homepage to TypeScript, we have several more, actually 2 more dependencies to get through. We're actually doing a depth-first search, fun fact, of our dependencies. We're going from the root or some arbitrary node root and then going straight down to the nearest leaf node and then back up, and then we keep hitting leaf nodes. And it's easier to convert leaf nodes because they don't have dependencies on other things that then need to be converted to TypeScript. So if they do have a dependency on something that needs to be converted to TypeScript, we go to that dependency first. In this case, movies list has a dependency on hooks/useFavorites, which has a dependency on use local storage item, which has a dependency on libs try parse. All right, we have found the next leaf node. It took us a little. Tryparse.ts. And here we see tryparse with an implicit any. Now I want to mention again that you don't have to fix all these type complaints to get your app to run. In fact, you don't even need to fix all your complaints in order to get the app to be converted to TypeScript in some cases. If you have a complaint from implicit any, you can always disable that. No implicit any, false in your TS config. That's actually the default setting unless you have strict true enabled. And as we go to this file, TypeScript knows and tells VS Code to grumble that this thing is implicitly any, and it might be able to infer a better type from its usage, but it's not an error. It's not a red squiggly. However, because this app is small, I like enabling no implicit any to start. Here we go. So what is tryparse? JSON.parse takes in text string, and data is passed directly to JSON parse. Oops, there we go. So I'm going to go out on the limb here and say that text is, or data is probably type string. Jolly good. And if we open the test file side by side and look at what's passed to tryparse, in fact, let's just go ahead and convert this test file too. Yep, data is type string in both, and it's happy. Hooray! We've converted our first non-component file and test to TypeScript. Tryparse is used by use local storage item, so let's just go ahead and convert use local storage item. Awesome. This file has a few more complaints that we're going to have to get through. Exciting. Now you may notice in some JavaScript files as you convert them to TypeScript that there are JSDoc documents, little comments above things. In fact, in TypeScript land we call that tsdoc, but not many people refer to it as such. That's okay. In tsdocs, you really don't need to declare what the type is because we have that in TypeScript. So I'm just going to go ahead and move this key string doc into the TypeScript land. Very useful, thank you JSDoc equivalent. But now we need to figure out what the rest of these parameters are. What is blank value? And if blank value is implicitly any, we need to also figure out what initial value is going to be because it defaults to blank value, which means it's probably the same type as blank value, as indicated by these asterisk types here, which I'm going to go ahead and delete. You also don't need to indicate that an optional param is optional because, well, TypeScript has an understanding. So who uses use local storage item? Find all references. It's used in a couple places. Let's look at them. It's used in use favorites and use sorter. Use favorite passes in a string, good. And then blank value and initial value, which are an object with a string key and a Boolean value. So maybe blank value is an object. But then in use sorter, it uses, oh, it just passes in blank value, which is the first element of this array, so a string. So in one case, use local storage item takes in a string, and in another case, it takes in an object. If only TypeScript had some way of saying that a function or component or class can be generic across a data type, that each instance or usage of it has a different version of that data type that must be consistent for that usage. Good thing it does, and they're called generics. I'm going to call this one value. This is how you declare generic. We say that whenever we use this thing, there's an unknown until usage type called value, which blank value is going to be. Now here we see that blank value is of whatever this value generic will be, this template. And then initial value, which defaults to blank value, is therefore also going to be type value. Great. So let's look through this code. We see that the useState function from React is, by the way, itself generic. It takes in a value, and the initial value is either, the initial state is either that value or function to generate that value. Fun fact about useState. And it returns an array with the value and a dispatch to set state to that value, which is what we have here. Item is value, set item is the dispatch, which is a function. And now we have a TypeScript red squiggly. And this is the first issue with our code that TypeScript has discovered for us. It's not going to be the last. Spoilers. It says that local storage.getItem returns string or null, but is being passed to, there we go, returns string or null, but is being passed to something that expects type string. Cool. Now try parse expects something of type string, but it's actually kind of okay that that we're passing null here, because if this throws an error, if what's passed to JSON that parse is invalid, it returns undefined. I might be able to think of an edge case where this is going to cause an error where it ends up being like string null or something, but just in case, it seems safe to me that we say that this should be string or null, and if data is null, we return undefined. Now, normally when converting from JavaScript to TypeScript, if you have a big app, I strongly recommend don't change behavior, because the ability to review a pull request decreases dramatically as the dependencies or the things that pull requests must do increase. I forget what word I'm trying to go for. But localhost get item returning string or null, and therefore maybe playing not well with try parse, that's a behavior change. And most of the time, I don't recommend changing behavior at the same time you're also adding a bunch of stuff in the type system. It's hard to review both. And in my experience, most of the bugs I've added when converting from JavaScript to TypeScript, in fact, I think all of them, have been because I tried to change behavior when TypeScript showed me something was wrong. So even though TypeScript is showing us something is wrong, I still recommend putting a little to-do, saying to-do fix me, and using some way around the type system. In this case, we can use the non-null assertion, which says, given whatever I had before, it's now not null or undefined. In this case, get item returning string or null is now asserted to be, just kidding, it's actually string. Cool. And now we have no errors. I do want to note, though, that this thing returns an array of a fixed size that is called a tuple. But we see here that this claims, if we hover over it, to return value or a function that takes in value as each member of the array. It doesn't know how long that array is or what the order of the types is. It could be everything's a function or everything's a value. It just says that there's an array of those things. And I'm not going to fix that right now because you might not notice this the first time you convert a component, but I'd like to note that this will come up soon as we try to improve things. as we try to convert to TypeScript. Oops. And one way that this comes up is if we convert the test file to TypeScript as an extension, and I thought this would complain. Okay, cool. Well, sometimes it's just flexible and works well. But let's see who use local storage item. Find all references, use sorter, use favorites. Here we go, use favorites is what we were on. Let's convert use favorites to TS. There's no JSX element stuff in here, so we can just use the regular TS extension. And here we see some errors. So let's dig into them first. First off, this name parameter is implicitly any. We haven't declared what it is. There's no way for TypeScript to infer it. So we've got to convert it to TypeScript by adding a type annotation. And just looking through the code, we see that name is used as the index key into favorites, which we know to be either the empty object or a function. That's just a little weird. But we're using it as a string key in an object, so it seems like it's very likely that it's a string, given that the variable name is name. But more confusingly is that favorites and set favorites are both the same type. They're both either an empty object or value any arrow or void. And this is because when you return an array directly, TypeScript doesn't assume that it's a tuple. It doesn't assume it's a fixed size array. Instead, it assumes it's an array of any size that you can later push to, because nothing in the type system stops you from saying do const x equals local storage item thing. Oops, I added an extra parentheses in my quick example, then like doing x.push. Like nothing stops you in the type system from this. So in order to tell TypeScript explicitly, this thing is a fixed size array. It's a tuple. I'm not allowed to push to it. The first thing is its own type. The second item is its second type. Is we do as const, which tells TypeScript that it's read-only. It's not going to change. And now we see that it's no longer allowed to .push because such a thing doesn't exist in a read-only array. And we see that favorites, if we hover over it, has its own type. It's this object type, which makes sense because that's the type of blank value up above, which is passed in. And set favorites now is that function that takes in value any and returns void. And the reason, by the way, value is any is because we never declared what the parameter type here on line 27 is in the other file. And in this case, I'm pretty sure that set item takes in value, and here we know it's dispatch, which is the React term for function that takes in an item for value, so we can convert it to value. We add a type annotation there. Cool. So now we see why we have to add as const to make TypeScript know that this thing is a tuple. By the way, another thing you could do here, instead of as const, is, moving this over, you could add an explicit array type annotation saying this is value, then value void. You could say that this explicitly returns this tuple. This is the syntax for doing so. But this is a little more explicit, a little more painstaking to have to write out. Kind of annoying. And I like just letting TypeScript infer from my types what things are supposed to be. That way I don't have to change multiple places if a bunch of stuff changes. So I'm going to go ahead and keep this as const. Great. One more little red squiggly. Argument of type value is not assignable to parameter of type string. This is correct. TypeScript has legitimately found a bug. And I know this because the original author, me, added a little thinking emoji here. The local storage.setItem takes in a key of type string and a value of type string, not of type object. Which means that if the blank value, or the value generic, is not string, this is wrong. Value might be something other than string. It might be an object. And we saw earlier in use favorites, that value is going to be some object type. So this is another issue that TypeScript has found for us. And in fact, it seems to me like this means that local storage setting of any item is broken. That if we were to open our app and go to local storage, we would see Yep, movie's favorite is object object. That's wrong. And if we use the app, I betcha this favorites feature won't get stored. Yeah, look at this. If you refresh the app, everything disappears. So TypeScript has found a real bad bug for us. Yay. And sure, you might have been able to notice the bug if you'd used the app and noticed that things weren't saving. But you gotta admit, that's a hard bug to find if you don't know that that feature is supposed to be there. This is one of the beauties of TypeScript, that it can find things wrong with our code much more reliably and much more statically than us going through the app, knowing about the app, and trying all the different user flows. So again, in general, I don't recommend converting to TypeScript and fixing bugs, but because this bug is just really egregious, I'm gonna go ahead and fix it. JSON.stringify is what you're supposed to do if you want to put something in local storage, because we're trying to parse it later. So now that I've JSON.stringified things, if I start to save stuff, switch to favorites only, and then refresh, voila, my favorites have saved. Yay, TypeScript. All right. One last little thing on this use favorites and use local storage item pairing is that sometimes TypeScript gets the generic wrong when you use things. For example, if you were to use the useState hook from React and you don't have an initial value, and then later on you set the value, let's say to a string, whatever, just once. TypeScript doesn't know what this value type is supposed to be. The useState defaults to undefined, there's no value there. So sometimes you have to explicitly say what the generic type is, which you can do by providing the generic syntax at the call location of a function. Here we explicitly say, I know it's not defined now, but later on it's going to be a string. So assume the value can be either string or undefined. For our local storage item, we are seeing the same issue where it thinks that the generic is this empty object, this empty object type, there we go, because the blank value is empty object and initial value defaults to it. The solution for this, again, is to explicitly use a generic type. But what type do we use? I posit that we use record of string to Boolean. What is record string Boolean? Glad you asked. The record type takes in a key type and a value type and gives you back an object that says for everything in the key type, so for every key of the object, you get back the value type, which is a really fancy way of saying that this is actually, everything is key strings, value Booleans. But I like using fancy built-in types because they make me feel good about myself, and I just like having a syntax shortcut to avoid all these squiggly, narrow brackets. So whichever one you prefer works. I personally prefer record. These slight and subtle differences don't really impact this level of code. Very simple. Yay! And now we get this squiggly down here removed. Side note, let's look at the reason why it was squiggly down there, giving us a red complaint. It was saying that element implicitly has type any because expression of type string can't be used to index type empty array. No index signature with a parameter of type string was found on type empty array. TypeScript was saying that it believes the type of favorites, which is the result of use local storage item, to be the empty object. I'm sorry, I said array, I meant object. It's the empty object, which has no keys on it, which means keys of type string aren't allowed. But we know that it's allowing any type string to be used as a key to give back a Boolean value. Thus, we have explicitly declared that it is type record string Boolean. Yay, TypeScript. This will come up later. Use favorites is done. Let's convert its test to TS. And aha, we have red squigglies already. Hook.result current of 1. Side note, I haven't been going too deep into the implementation of these tests or some of the components of hooks. And that's because when you're converting to TypeScript, you don't always need to. Sometimes you can just skim over and add a few types here and there, and you don't have to have a full understanding of the components. Sometimes you do, like when we saw that local storage set item bug, but sometimes you don't. So as a time efficiency saver, although you can use converting to TypeScript as an excuse to learn all your code, you don't need to. Here, in theory, I could figure out how to, say, use the React hooks testing library in this test and figure out how all this stuff works. Or I could look at directly the issue and read the error message and see that this current thing, which I'm guessing is supposed to be the result of the hook, it is a type record or function array. And remember, wait a second, the array being a regular array and not a tuple is the same error I saw and fixed when I asConsted. Voila. AsConst, the error went away. Now we know current is the read-only tuple, where the first thing is the value, the record, and the second is a function. Yay, tuples. All right, use favorites is done. And now we're back to movies list, and we see the next two dependencies, use favorites filter and use sorter, or hooks, and after that we have one more component movie. Let's look at the hooks. Use favorites filter is a hook that calls a component select. All right. Now that we've finished converting a bunch of hooks, this should be easy peasy, right? We have a component. We have an interface for it because we want to allow these props to be defined. Typically call that component props interface select props, the name of the component plus props. We have onChange, options, and selected. What do these things do? Well, first off, let's look at onChange. Sometimes when you're trying to figure out what a component prop does, you can look down into the component. And or other times you might need to look up into the component's usage. Here we see down that select is providing onChange to the onChange of its select. What a mouthful. And in this case, the function, the prop onChange, is being called with event.target.value, which is type string. And the return result probably isn't being used because we never really use that in onChange. So I'm just going to go ahead and say that this is value string void, the function. Bada bing, bada bang. And if we look at the way select is used, it's got an onChange, which is set filter name, which is the function returned by use local storage item, which is a function that, haha, takes in a value string and returns void. Beautiful. It matches up. Let's move on to options and selected. Now options is an array. You see it's options.map. And here it's being passed in as filter names, which we can hover over and see is type string array. We can also visually see from its declaration up here that it's the result of object.keys filters, which is the result of object keys string array. So we know that options is string array. Woo! 2 down, 1 to go. Lastly, selected. If we look down, we see the value can be string or number or a read-only string array or undefined. So that's a good amount. And then if we look above, we see that filter name is passed in as a string. TypeScript, if we hover over, sees its type string. And visually, we see it's the local storage item hook results that defaults to filter name 0, which is string because it's an array of strings, get the first item, and use local storage item here has a generic of string. Therefore, selected is of type string. Select is done. Fun fact, later in this workshop, I will show some extra fancy things with select, but for now it works. Let's convert the test. Beautiful. Fun thing about jest.fns and tests, they work really well with component props that are functions. OnChange here is a just.fn, and then later we expect OnChange to have been called with banana when we select the banana option. If you weren't using jest functions, if you didn't have a good mock library, you'd have to do like let results string, and then OnChange is value string, result equals value, and then we'd have to do like expect results to equal, but then TypeScript would complain because there's no actual guarantee that result is being set. So saying it's always a string is wrong. If there's a bug in the component and unchange doesn't get called, then it wouldn't be a string at this point. So the valid correct way would be to say it's a string or undefined. And that's just a lot of code. Look at this. This is too much. This is like 4 lines here. So I'd rather just keep it as a just fn, which plays really nicely with TypeScript. Beautiful. All right, select is done for now. Going back up to use favorites filter. It also has a dependency on use local storage item, which we've already converted. So we can convert this thing to TypeScript. And we're calling it TSX because there's some JSX syntax. All right, this is going to be the first relatively more complex file that we convert to TypeScript. This thing is going to use generics. It's going to use record. It's going to have to infer some stuff from its calling component. Exciting stuff. To start, we have a whole bunch of things and we don't know what they are. We know this takes in a favorites object, which is later then passed to these functions up here. We see filters of filter name, or filter name's a string. It returns this favorites select, which is the JSX, and it returns this filter function, which takes in a movie, and then calls filters of filter name on favorites and that movie. Well, I can't really tell from just this file what all that stuff is supposed to be. And I can't look down because that doesn't give me any real benefit. I can only look at select and make deductions on use local storage item, which is not useful. I already know what all that's supposed to be, which means I'm going to look up. I'm going to see who uses this thing. In this case, it's movies list. All right. Now, even though movies list isn't yet converted to TypeScript, we can still make some deductions from it. For starters, let's say if we're trying to figure out what this favorites parameter is typed as. We see use favorites filter is called on favorites, which comes from the use favorites hook. And we've already converted this to TypeScript, and we know that the favorites returned is a record of string to Boolean. And sure enough, favorites, the first item in the tuple, x0, is passed directly to use favorites filter. Yay! That means we know favorites is a record of string to Boolean, an object with string keys and Boolean values. Great. Next, let's look at what this thing returns. We know what favorite select is. It's a JSX element. Ooh, wait. TypeScript thinks it's JSX element or function. The asConst tuple thing always gets me. Change it to asConst over there. Very good. There we go. JSX element and function. And then we see filter is passed to movies.filter. And movies.filter.sort.map makes me pretty sure movies is an array, which means filter is a function that returns a Boolean, which makes sense because it's returning the result of one of these 3 functions, which return Boolean. At the very least, this one does. Which means movie is whatever the heck movies list takes in for movies. This is an array, movie is one of them. And what does movies list take in, pray tell? Whatever the home page gives it, which is movies, which comes from the prop, which comes from get server-side props, which comes from the import of data / movies JSON, which means whatever's in this file, whatever's in data movies JSON, these things is the type that's passed to use favorites filters filter method. Now this brings up a pretty common occurrence in TypeScript. You have some data stored in a JSON file or a database or GraphQL or somewhere, and you need to type it. If you're on a really nice advanced ecosystem like GraphQL or Swagger CodeGen or something like that, you might have some auto-generation going for your types. You might be able to completely generate a whole bunch of TypeScript types from, say, a GraphQL schema and queries. That's how I personally like to live. It's awesome. But for this very small little contrived Next.js app, you might have to write your types by hand, which is what we're going to do here today. So under our movie data folder, we're going to write types ts. And we're going to say that there's, let's say, a movie data interface. And I'm calling it movie data because there is a movie component here, and I don't want to call it movie and then have it be confusing which one is which. So I'm just going to call it movie data. It's got what? Description, string, ID string, name string, starring, now this is exciting, string array, and year number. Okay, now later on in our types, in our TypeScript code, we can import from this movie data file. We can say that movie is :movie data. And by the way, fun fact, if we either press enter or click the little blue light bulb, click import, it'll auto import for us. Love that feature. My favorite thing in the world. One of. And now we know that this useFavorites_filter function returns favorite select, which is a JSX element, and filter, which takes in a movie and returns something. Let's figure out that something. Well, filters here is an object which seems to have string keys and values that are functions that return Boolean and take up to 2 parameters, one of which is favorites and the other of which is movie. Well, we know that favorites is record string Boolean from here, because that's what's passed. Filter is a filter name, parentheses, favorites. And we know that movie is of type movie data, because that's also what's passed in this filter, which means we can set up a function type alias, type favorites filter, which takes in favorites, record string Boolean, and movie data, and returns Boolean. Now this is a way of saying in the type system an alias, whenever I say favorites filter, what I really mean is this thing here. And I'm going to say filters is a record of string to favorite filter. Oh, look at that. Look at all those red squigglies go away all of a sudden. How did that happen? Well, TypeScript knows that filters is a record of string to favorite filter. And these functions take in 2 parameters, both of them. And because TypeScript knows the shape of this filters object, it therefore knows that these functions take in whatever favorite filter is described as taking in, a record of string to Boolean, and a movie, which is of type movie data. And now TypeScript can infer what this is supposed to be, which means filter is a function that takes in a movie and returns Boolean, and therefore this whole shebang returns a tuple with a favorite select elements and a function to filter. Beautiful. 2 lines of code at the top up here, and we inferred half the function, half the component hook. Let's look at the unit test. This thing looks kind of complicated. I don't really want to do anything here. Fortunately, I don't have to, because it's all inferred. Yay. A couple notes, though. Act, TypeScript is telling us, is declared but never read, which is an unused variable. I'm just going to delete that. And secondly, this thing has its own fixture dependency, create stub movie. I'm going to go to definition there. Now this is a pretty common pattern in React and general JavaScript tests. You have some kind of data that's commonly used, in our case movie data, and you'd like to create some instances of that for your tests. In this case, use favorites filter tests, create an apple and a banana instance, 2 of them. Now you can manually recreate description, ID, name, starring, yada yada, in every instance of them. Or you can create a create stub, create mock, whatever function that creates them with only the overridden fields you need. Useful. A little more tricky to type in TypeScript, but still very straightforward and doable. Movie TS. The overrides are going to be an optional parameter, and they're going to take in what we would describe as partial of movie data, hitting enter to auto import. This is saying that the overrides, which don't have to be provided, are any of the values summed to none, or however many you want, of movie data, the type. And we're spreading them, ... overrides, on top of these defaults. A bunch of blank strings, empty array, 0. And just to be safe, we're going to say that this function returns movie data. So no matter what, at the end of the day, if you call this, you get back movie data, which is what they're used for in the test file. And immediately TypeScript gives us a whole bunch of red squigglies saying ID is wrong because undefined isn't assignable to type string. You may notice that we forgot to put ID in our stub data. So I'm going to do that now. Great. Compiles happily, everyone's joyous. And just to be sure, I'm going to yarn test use favorites filter. Even though I'm on NPM, yarn still runs as a task runner, and I like not having to pass in my dashes from my run scripts. Yay, it passes. Great. Love it. All right, use favorites filter is done. We have converted our most complex hook of the session. Good for us. It's all easier from here until the end. Use sorter, our next hook to convert. It uses select, which we already converted. It uses local storage item, which we already converted. And thus, it is ready for conversion. Use sorter.tsx. Looks like it also makes a select. And fun fact, this looks suspiciously similar to use favorites filter. So we get to do one of my favorite things in programming, which is copy and paste. Love copy and pasting. In this case, it's not favorite filter, it's favorite sorter. And it does what array.sort does, which is take in two things, both of type movie data. I'm gonna right click, left click, click the light bulb, auto import. And then sorters is record of string to favorite sorter. Oh no. Number is not assignable to type Boolean. Yep, because sorting returns a number, not a Boolean. Oh, look at this. Look, beautiful. This whole thing. 2 lines and it's no more red, no squigglies. Sorter, yep, is a favorite sorter. We return the JSX element. Aha. Gotta as const. Always gotta as const down here. Use sorter.test. Make sure we got this right. And yep, everyone is happy here. No complaints. In theory, test files, in my experience, have more than just the occasional unused variable, but for the sake of keeping this workshop to a reasonable time, I have not gone over those. And now that use sorter is done, we can move back up to movies list and tackle our last movies list dependency component, movie, which has a dependency on favorite star. Okay. Let's convert this to TypeScript. All right, we see pretty quintessential situation for a React component. It's missing props type, favorite star props. Copy and paste that to be the interface name. Oop. Class name and favorite. What are these? Well, let's look down. We see that favorite is checked to see if it's truthy, so it's probably a Boolean. And class name is provided to CX, which is the common abbreviation for class names, the popular class name concatenation library. And then again, favorite is used truthiness. So it's probably a string for class name and Boolean for favorite. Let's look. Ooh, lordy, look at this. Movie has an unused variable. Haha, thanks TypeScript. And favorite star takes in favorite, which is whatever is passed to movie, which takes in favorites and movies ID. Aha! Favorites and movie ID. Movie.id is a string. What is a movie? Well, favorites is a record string Boolean, so whatever it takes in as a key, the value is going to be Boolean, which means movie if favorite is a Boolean. So I'm actually just going to make a note for that here for later. Boolean. And thus favorite here is a Boolean. Yay! And let's look at class name. Class name here, styles.star. Well, styles is what gets imported from module CSS, which is, we know in our heads, string, even though this JS file hasn't been converted to TypeScript yet, which means class name is a string. Yay! Before we move back to movie, we can convert favorite star test TSX. And yep, no complaints in this taskbar. Great. Favorite star takes in a class name and a favorite of type string and Boolean, respectively. Let's convert movie. All right, we've got this interface props that we're going to have to write. And we remember that favorite is type Boolean. All right. 3 props, only 1 is typed so far. Let's look at movie and toggle favorites. Well, movie is taken in as a prop. It has movie.name that's used, movie.description, movie.starring, which is an array of something. This is almost certainly movie data, the type that we made for our data. But just to be sure, now that we're done looking down, movie.year, we can also look up who uses movie, find all references, movies list, which passes movie equals movie, where movie is of type any, but it's what we take in as a prop, which I'm pretty sure we saw earlier is movie data array, which means we can be pretty sure that movie is movie data. Great, because movies list takes in movie data array and passes each movie to movie. It's on Twister. This is almost certainly movie data. And look, it just matches up nicely. Now, what is toggle favorite? Well, first it's passed a button on click, takes in a mouse event handler, and let's look where else. Ooh, it's also passed a favorite star with a red squiggly. I'm going to put down a new line to make it easier to read. And the red squiggly is saying type class name favorite toggle favorite is not assignable to type intrinsic attributes and favorite star props, which is the fancy TypeScript way of saying the set of props you're giving to this component isn't allowed. It's not on the set of props that the component takes in or that all components take in, which is key. Property toggle favorite does not exist. Aha! Favorite star does not take in a toggle favorite. TypeScript found dead code. Yay, TypeScript. There is no need to pass this toggle favorite prop. It's not used. Dead code. Kill. Which means toggle favorite is only used by this component in one location. On click equals toggle favorite. And if we look back up, toggle favorite is, yep, a function that takes no parameters, and then seems to me like we ignore the output. Toggle favorite movie.id, which is the result of use favorites. Oh yeah. So that's great. This thing returns void. Here we pass in the string. So this toggle favorite is a function that takes in nothing and returns nothing. Love it. Now to be clear, the function in movies list called toggle favorite takes in a name, but here we bind it, or we pass a function that uses it, and the function that uses it inside movie does not take in a parameter. In a sense, we're doing what's called currying. We're binding this function to a particular parameter, in this case movie.id. So yay, our movie component is TypeScripted. We even found some dead code. Good for us. Now movie has a test. Spoiler alert, no complaints here. We've already converted to create stub movie. Fine. Sometimes in test I'll see people putting extra things like, I don't know, like production started or something like this. And then you'll find when you add types to things more dead code. But for now, these tests are pretty clean. All right, movie's done. Moving back up, we can finally convert movies list. Very exciting. TSX. You know the drill. Export interface. Name of the components, so movies list props. And here we only have the one prop, movies, which we previously noted are almost certainly type movie data. So we can import from data/types. Oops. Let's copy paste that name so I don't mess up. Beautiful. This is something that's going to happen pretty frequently as you convert from JavaScript to TypeScript. You'll find that once you get towards the end of the conversion, once most of your leaf nodes and middle nodes are converted, you can infer most of the types from your dependencies in each component. In this case, I declared that movies is of type movie data, and everything inside the movies list was inferred. Favorites, filter, sorter, select, all this stuff is known because the dependencies of this component are converted already to TypeScript. Awesome. Now if you look at, well, movies list doesn't have a test file, shame on me, the author. So we can go back up to pages index, and we have one last little component to convert. Title TSX, export interface title props, takes in children. At this point, it doesn't really matter what we put as long as it compiles. But yeah, title takes in some arbitrary JSX node, which means it's almost certainly React.React node. Yay. All right. That was a straightforward little component there. Fun little thing on the side. So let's look at home, our last major component to convert. At least the last one more than a few lines. Index.tsx. And 2 squigglies, not so bad. To start, we got to declare our home props. Please. And pretending that we didn't remember already 4 or 5 separate investigations, concluding that something called movies is of type movie data array, we can see that it's what's given to us by importing data/movies.json. And we see it's the type passed into movies list.movies, which is movie data. So pretty clearly to us now, movie data, which I can now import automatically. And we have one last red squiggly in this file, span href. There is no real purpose in most apps to add an href to a span element. You might add it to an A or anchor element, but not to a span. And if we look in the production code, it seems to me like someone, the author, copy and pasted this repo from the Next.js starter and forgot to remove the href when they converted this from an anchor to a span, because it does nothing. It's not clickable, which means TypeScript has yet again found unused code. Yay! My sloppiness is our lesson. Great. So we have successfully converted basically every user land component in this app. One last component convert time, yeah, pages app TSX. Now this one's actually a little tricky, even though it's only 7 lines, because this is part of the Next.js infrastructure we're plugging into. We don't pass things to this component ourselves. Next.js does that for us. So whenever you find some infrastructure shenanigan in a framework you have to convert to TypeScript, you can either leave it as JavaScript, which honestly is not a terrible idea if it's something you don't really need to be type safe. For this file, 7 lines, Or you can look up how to do it. Next.js, TypeScript. Okay, basic features TypeScript. Let's see if they have something about app in here. Create next app, ... Custom app. Here we go. They're telling us to import type app props from next/app. And app context, I don't use app context, so I can keep that common to that. And this is app props. Look at that. Easy peasy. So not only did we copy and paste earlier for great benefit, now we're Googling and copy and pasting for great benefit. One little note, the Next.js app is docs, so using import type, which is like an import statement, but only allows things in the type system. You can't accidentally import some function or variable. Fine, nice to have. And because we renamed app from JS to TS, Next is now mad at us because it can't handle that. So I'm just going to go ahead and restart my dev server and refresh the page. Yay! The app works. Glorious. Wonderful. Although the workshop is not done, at this point, we have successfully converted our app from JavaScript to TypeScript. The source code is completely TypeScriptified. Yay! Good for us. There are two more things which are not 100% essential. Linting with TypeScript Eslint, which I still strongly recommend, and then getting slightly more type safety at the expense of readability in a couple of our hooks, which is more of an extra credit bonus. But at this point, you can leave the workshop feeling good. Yes, it's been an hour. I can successfully convert Josh Goldberg's sample JavaScript Next.js app to TypeScript. Yay. Let's pause, feel good, and then we'll move on to the two last things. Just to recap, repo is on GitHub. Boop. Okay. TypeScript Eslint. If we were to add some bad thing, let's say a var variable that's unused, ASDF equals lol what, in theory, npm run lint should detect this as a var and tell us, no, you're not allowed to use var, you should use letter const. That's kind of the standard Eslint preset that people use. That's one of the rules that's enabled. This one isn't. And the reason why is that Eslint does not natively work on language extensions like TypeScript or Flow. It is only for JavaScript out of the box. In order to use Eslint with a language such as TypeScript, one must use a tool like TypeScript-Eslint. Years ago, there was a tool called Eslint. I was actually one of the last maintainers that helped with it. That was a direct TypeScript linter equivalent to Eslint. The tool is not as good, had some political badness associated, and we have stopped using it. It is dead. Don't use Eslint. Thanks. Instead, we use TypeScript Eslint, which is a plugin and a parser, an extension on top of Eslint that allows you to use it with TypeScript code. Don't use Eslint. Going through the README, getting started, read the getting started docs. I want to lint my TypeScript code base. These are the dependencies one must generally use. We already have Eslint and TypeScript as dependencies, so I'm going to show these. We use the TypeScript Eslint parser, which parses in JavaScript files into a tree, abstract syntax tree, or AST, that's readable by the TypeScript Eslint and Eslint rules. And then we use the TypeScript Eslint plugin, which sets up a bunch of custom rules in the runtime in which, on top of Eslint, we can run our TypeScript Eslint rules. If that's all gibberish to you, that's fine. Don't worry. Just run this command and it'll work. And add to your Eslint RC.js file. But I love this stuff, this linting stuff. I think it's really cool. And it's super useful as a developer to know how we actually lint, how we understand code. So copy and pasting the configuration here. Let's see, we have two extends. Next.js comes with a couple things. So I'm going to add the Eslint recommended and plug in TypeScript Eslint recommended. In fact, there's one more rule that's mentioned not in this file, but in other files they have. We should really add to this file. Recommended with type checking, which enables some really powerful Eslint rules that use TypeScript. And then we say root true. I still don't know what that means or what it's for. Parser is a TypeScript Eslint parser, and we add plugins TypeScript Eslint to be able to use them. Okay. Again, it's fine if you kind of glossed over for most of that. Oops, wrong command. But the TLDR is you should now be able to lint your code and get complaints. Oh no, I probably typed this wrong. Let's Google it. TypeScript Eslint recommended type checking requiring. There we go. Recommended requiring type checking. Requiring. All right, npm run lint. Oh no, that's right. In order to use these type checking files, we need to tell it parser options project tsconfig.json. There are some really powerful TypeScript Eslint rules that use TypeScript's language services, its compiler, technically it's program type checking APIs, to get really, really powerful intelligence about your code. Things like, are you spinning off a promise and not adequately handling whether it fails or rejects? In practice, most of the complaints are actually not so powerful, but it's nice to have them at our leisure. I will note that I don't agree with all built-in TypeScript Eslint rules. The most important thing to remember about a linter such as Eslint is that it works for you. You don't work for it. So if you disagree with a rule, I highly recommend first research the rule, see why do I disagree with it, is that wrong? In this case, I'm going to reload a window because the Eslint extension needs to be refreshed. And the rule that I'm getting annoyed at is this TypeScript Eslint explicit module boundary types rule. I personally don't agree with this rule. It says that every function that's exported should have declared return type, not just declared parameter types, which is reasonable in a really big TypeScript code base where that actually is beneficial in some ways for TypeScript performance. But on small code bases, it's just kind of annoying. So if you really want to read more on it, VS Code and other extensions or IDEs, their extensions have links to the docs. I'm going to click here and get taken to the docs page for this rule. But I'm just going to skip right ahead and disable the rule in my Eslint config. Copy and paste. Rules, this thing, off. All right, now if I run npm run lint again, well, first of all, the extension stopped giving me yellow squigglies here, so that's nice. Second of all, now I have just the two real rules that I wanted to complain on. No var and an unused variable. Unexpected var, use letter const instead. Fun fact, it can actually fix the problem by converting it to let, but it's also an unused variable, so I'm going to remove it. Very nice. If we run lint again, no complaints. All right. Let's recap. In our package JSON, we added a couple libraries. We added TypeScript Eslint plugin in the parser. Parser parses, plugin adds rules. We then pre-configured our ESLints to extend from a few recommended things and use the parser with our tsconfig and use the plugin, and then we disabled a rule that I find annoying. Great. We have added TypeScript Eslint to our TypeScript project that uses React. Yay. Very good. Next up, I wanted to follow up on something earlier. Use favorites filter. Now, here we said that filters is an object where every key is type string, and every value is this function. And while it's true that every value is that type function, for the strings we've provided, these three coincidentally always used ones, in practice, this record string to favorite filter is not quite accurate because filters of blah, 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 ASDF, this doesn't exist. But in TypeScript, we said any possible string is allowed as a key. And it's really only been a coincidence that our code doesn't accidentally mess this up. We haven't like hard-coded the thing to like favorite, like nothing favorited. Like this very blatant typo for a couple of reasons. This completely is fine in TypeScript. In fact, I'm going to keep this here just to show that we should get a red squiggly on it, but we don't. So a slightly more type-safe way to do this would be to say like type filter name, and then is all or favorites only, or, oops, that's an uppercase, or no favorites. We're saying that this type alias says not just any old string, but one of these three specific strings is allowed. And then we use it on this record. Aha. And now we say use local storage item isn't just being used with type string, it's specifically being generically used with filter name, which tells us that nothing favorited is not allowed. We need one of the filter names. But then this is also slightly more complicated because object.keys, intentionally for good reasons, doesn't return what TypeScript knows to be the keys. It returns string array because someone might have extended the objects elsewhere and passed it into a place with a more restrictive type. Fine. So we need to cast this saying it's not just any old string array, it's specifically an array of strings that are one of these three. And now we know that filter name is specifically one of those. But now we have one slight issue. The select has a complaint because onChange says that you're passing in a thing, a function that takes in parameter of type filter name, but I being onChange from select, may pass it any string. Select is saying, I have no idea what these strings are, they're just any string, so I might call onChange with event.target.value, where value is any string in the world. That's an issue. And this is a fun thing. You can make React components generic. You can say that, let's say, option values has to be some kind of string, and select props is itself generic. You can make interfaces generic. So let's call it singular option value. So value is of type option value. Options aren't just any old string array either. It's string array, option value array. And selected, whatever is selected, is only going to be type option value. So now we've made our component generic so that the usage of this component here knows that onChange is only ever going to receive one of the filter names. In fact, you can be explicit with it. Look at this beautiful syntax here, filter name. Oh, just love a good generic syntax. Displaying that across lines for readability temporarily. And then the last thing we have to do is we have to explicitly cast that onChange of event.target.value. The HTML, React, JSX types don't know that value is specifically option, caps out of excitement, option value. Now we have slightly more type-safe code. We had to define a generic in a couple of places. But now our use favorites filter is more specific and more somewhat type safe. Similarly, because we copy and pasted, now we have to update use sorter, which is also sorter name. Oh, what a pain. I'm going to use quick little VS Code shortcuts. I multi-selected with option command down and then option command shift or command shift left and right to, what was it? Yeah, option shift right, there we go, to select multiple things and copy them. So type sorter name equals this. Yeah, look at beautiful VS Code shortcuts. So now we see as sorter name is possible here, and I'm just copying the same stuff I did in use favorites filter. I'm going a little fast because it's the end of the workshop and you'll be able to see this in the resultant pull request anyway. So this actually doesn't need to be explicitly generic because TypeScript can infer the generic. Look at this, option value extends string. Yeah, so slightly more type safe, but debatable whether that's actually worth it. I find this to be less readable code. I find it annoying that we duplicated things. The alternative to duplication would be we could do filter name is key of type of filters and remove the type annotation on filters, which is saying to TypeScript, don't infer the type of this to be record string Boolean, infer it from its actual initial value, which means filter name is one of the three actual keys. But now, because we're not telling it explicitly that it's about type filters, we have to manually record string Boolean here and then movie data because we didn't use this type anymore. So debatable whether that extra type safety is worth it. In this case, probably not because, well, it worked. It's pretty simple components. In practice, depends on what app you're running. But I'll leave them in just because I already got to them. So that's the whole workshop. Thank you for attending. Thank you for your active participation and, I assume, great comments in the chat. Everything here, again, is open source and online. You can see it on Next.js to TS. I'll send a pull request right now, actually. Let's see, git checkout be TypeScript, git converted to TypeScript, sparkles, push origin TypeScript. Glorious. So yeah, you'll be able to check out this pull request online. Love my emojis. Let me know if you have any feedback or thoughts, and let me know also if you can, or if you'd want my help in converting anything else to TypeScript. I'm Josh Goldberg. You can find me on GitHub, on Twitter as Joshua K. Goldberg, and my website is joshuakgoldberg.com. Thanks. Have a good one.